Hello friends, so welcome to the second session of motion in one dimension, that is motion in straight line. And in previous session we had discussed about what is motion in straight line. Then we had learned about what is path length, what is displacement, what is average speed, what is average velocity. So with all this concept, the summary is that when a thing is changing its position with respect to another object, it is said to be in motion. The difference between final position and initial position is called displacement. Displacement is in a particular direction. So here, as we are discussing motion in a straight line or motion in one dimension, that means either this displacement is in positive direction, that is positive x-axis, or towards negative x-axis. So these are the only position, right? So we had discussed about what is average velocity. So when the distance, that is position changing with respect to time. So for different time interval, if the position is different, then we can find out what is the average velocity, right? So today let's introduce the concept of particle. So whenever we learn motion, the object can be of different size. So if the object is solid, we generally consider that object as a particle only. So all the particles of that object are going to carry out same motion. So that's the basic assumption. So this is valid in certain cases and not valid in certain cases. We are not going into the detail of those elaborations at present. So physical size of object is what we have not considered in this study, right? Now the thing is, this is concept of reference frame. Consider this bag. So this bag is stationary for the the passenger it is carrying and traveling in the train itself, right? But the person who is here, the person who is standing outside the train, is able to see the train and the bag moving. So for him, the bag is in motion. So how can we know that the object is in rest or in motion? It is with respect to the frame of reference. So the frame of reference is nothing but a place or situation from where an observer takes his observation is called frame of reference, right? So place or situation. So based on that, the object can be either in motion or it can be in rest. There are different time of reference, different frame of reference also. The frame of reference itself can be in motion, right? You can assume a car moving parallel to the you can say train, and then observing the motion. So altogether different criteria will be there. At present we will not complicate the matter, but this is motion in one dimension, and different frame of reference are possible, right? Now when we want to study the motion and motion in straight line, the position versus time graph, that is x t graph, they tell us they give us a lot of information. So let's see what are the x versus t graph. So x is position and t is time. So with respect to time, suppose we have different positions. Okay, let's plot and see. So let's say the situation is like this, that I have two axes. On this axis I have time, and on this axis I have a position. So if for different time the position remains same, that means you can see over here the object is at rest. Its position is fixed, not changing with respect to time. So what is average velocity of these objects? Cx2 minus x1 divided by t2 minus t1 is going to be 0 because x2 and x1 are same. So this is the graph which tells the object is stationary and velocity is 0. So this is the first case. Second case, so let us say the position versus xt graph is a straight line with non-zero slope. The first was also a straight line, but it was parallel to x-axis, and its slope, that is tan theta, was 0. Now, this is a straight line where slope is not 0. It is having a positive slope. So you can see over here that this is the instant t1 at which the position is x1, and here it is x2. So whatever is my positive direction, say positive x-axis, so x2 is greater than x1 and t2 is greater than t1. So average velocity is nothing but x2 minus x1 over t2 minus t1 is going to be positive number. So this is the graph which is telling me that for any time interval, if I measure, the slope is going to remain same because it is a straight line with say given slope. So the slope is this ratio, average velocity. Therefore, this straight line tells me that the velocity of this object's motion is constant. And such a motion is called uniform motion. Constant velocity motion. Continuously this position changing with respect to time, but with the same velocity or constant velocity. So this is the second case. Third case is where we have a graph like this. This is position, this is time. We have a graph with negative slope. So this negative slope tells me that the average velocity, which is nothing but x2 minus x1 over t2 minus t1, is going to be a negative number. So it is negative velocity. Now, what do you mean by negative velocity? So if this is the motion direction positive x-axis, then actual motion is in opposite direction. That is with constant velocity itself, but in opposite direction. So that is how you interpret this curve with the negative slope. So the initial motion was with this, and then now the motion is in opposite direction. So you can see over here that this is x2, x1, and this is x2, and this is T1 and this is T2. So if you take the ratio over of x2 minus x1 divided by T2 minus T1 is going to be a negative number because x2 is less than x1. So this is, you can see from graph we can find out whether the motion is in forward direction or is in reverse direction. And fourth and last case, if the graph is such that you cannot find, say, the shape is something like this. So it is having different position at different time. Then this is that you cannot comment on the velocity on and hold. So such a motion is called non-uniform motion. Right? So likewise, these are the four type of curves which tells you about what type of motion it is there, right? So motion can be, you can say velocity can be 0 if the line is straight line like this, positive velocity and constant velocity uniform motion. You can have a negative velocity. This is again the uniform motion because velocity is constant, but motion is in opposite direction. And then you can have a non-uniform motion also, right? Now next is the concept of instantaneous velocity. Now this is valid only when the velocity is changing with respect to time. When velocity is constant, you have uniform motion, then instantaneous velocity and average velocity are going to be same. Now the thing is that suppose we have a different time interval. You can say I have a time and I have a, you can say, velocity table. So for different time, you can say time 1, 2, 1, 3, 5, 7, something like this. I have different speeds over here, say 5, 10, 15, 18, and something like this. So you can see it's not a straight line relation. And at the same time, at different time intervals, I have different average velocity. Uh, so I can find out in a particular time interval how much is the average velocity. Say in first time interval, the average velocity is going to be, you can say it is 10 minus 5 divided by 3 minus 1. So that is going to be 5 by 2 or 2.5, you can say, meter per second. But within that, at 2 seconds, what is going to be the velocity? That is something which I cannot tell. It is the duration in which this is the variation, right? So now what I have to do if I want to find out the instantaneous velocity at t is equal to 2 seconds. So what I have to do, I have to reduce this time interval to very small value. So we know this average velocity is a ratio of delta x, which is nothing but the uh, change in position divided by delta t, which is nothing but the time interval. So if I want to find instantaneous velocity, which is say like this, then I have to reduce this time interval to such a tiny value. So mathematically it is said that if I reduce this time to almost very small, you can say, value, delta t tends to 0, then in such a situation this ratio is going to give you me instantaneous velocity. Right, so this is the definition of instantaneous velocity. It is the application of limit or calculus which is helping you, and this is mathematically said dx by dt. So it is nothing but the differentiation. So in mathematics, you are going to learn the differentiation, and this is the application. So if you have a, you can say, average velocity, differentiation is something which gives you instantaneous velocity. So mathematics is helping science or physics, and physics is the reason because of which mathematics gets developed, right? So they both are interdependent, and that is how we realize it. Suppose we have a graph. From that, how can we find instantaneous velocity? So let us say I have a okay, leave it. Suppose I have a graph in this fashion. Right? So this graph tells me that this displacement is changing with respect to time, and it is not having a constant slope. So what do I know with the measurements? I know this time interval, say t1, t2, and what are the displacements x1, x2 in this region, right? So when I want to find out at this instant, say you can say this instant, you can say t, I want to find out what is the velocity. Then average velocity formula I know, but instantaneous velocity, how can I find out? So I have to narrow down this time interval. I have to reduce. So when I keep on reducing the time interval, ultimately I get a situation where at this point, if I draw a tangent is a line which is touching this curve only at this point, and this tangent is having certain slope. So slope of this tangent in case of non-uniform motion, I'm talking about the slope of this tangent at the point P. Suppose this is the point P. At point P gives the instantaneous velocity at point P, right? So instantaneous velocity graphically can be found at any point if you draw a tangent to the that particular curve. In case of non-uniform motion, if the graph is a straight line like this, x versus t, that at any point you can say velocity is same. So average velocity or instantaneous velocity are one and the same thing, right? So that's how we define the instantaneous velocity. So we have defined instantaneous velocity. Now let's go to the acceleration. So when we study motion, once again let's revise what we have learned so far. We have learned so far that when things are in motion, that means they are changing their position with respect to another object. So we have a common frame of reference. With respect to that, we study whether the things are in motion or they are stationary. But that change in motion is also having, you can say, with different time interval, the rate at which this position changes may also be different. So if the velocity of that particular object or particle is changing with respect to time during the motion, we say it is having accelerated motion. So acceleration is nothing but change in velocity of a object in motion with time interval. So average acceleration A is defined as velocity v2, average velocity v2 minus average velocity v1 divided by t2 minus t1, right? And also it is a vector quantity, and the direction is in the direction of change of velocity. So direction is in the direction of change of velocity. So as this is motion in one dimension, so acceleration can be in positive x-axis dimension, or it can be in opposite direction, right? So acceleration can be in one direction or the other direction. It depends on whether the change in speed is positive or negative, right? So acceleration positive means if v2 is greater than v1, then we have alpha is equal to v2 minus v1 divided by t2 minus t1 to be greater than 0. So we say it is positive. What is the unit of acceleration? You can say we have velocity as say acceleration is nothing but velocity divided by time. So it is meter per second divided by second. So its unit is meter per second square, right? So meter per second square is the unit of acceleration, and acceleration is positive means acceleration is in the same direction of the motion. If the motion is in this positive exact direction, you can say, then acceleration is also in the same direction, and velocity is also in the same direction. If acceleration is negative, that means the velocity is reducing, so acceleration is in the opposite direction to that of the motion. So with negative acceleration, motion and acceleration are in opposite direction, right? Now velocity time curves, once again, just the way we study the xt curves, we can study vt curves. So they also tell us a lot of information. Like first case, if velocity is constant with respect to time, this is v and this is t, then this is called the uniform motion. and this is the situation where acceleration is 0. Because you can see velocity is same with respect to time. So for different time interval, velocity is same. So v2 minus v1 is 0. Therefore, acceleration is 0. Such a curve is indicating the uniform motion. The xt graph for such a case is going to be like this. Right. Now, second case is where you have uniform acceleration. So if suppose the graph is a straight line with constant slope, so this is the graph indicating the acceleration is constant. Of course, it is positive because the slope is positive. So such a motion is called uniform accelerated motion. This slope can be positive also, this slope can be negative also. Let's say the third case where you have a situation like this. So this is V and this is T. So here alpha is V2 minus V1 divided by T2 minus T1, which is less than 0 or negative. So negative acceleration indicates that the acceleration is in the opposite direction, right? So speed is reducing rather. It is also known as retardation acceleration, right? And similarly, if the velocity versus you can say time curve is having some strange curve shape, and it is non-uniform motion. So it is non-uniform motion. Acceleration itself is also not uniform, right? So this is the study so far about the velocity, instantaneous velocity, xt curves, velocity versus time curves, and how you can predict the motion from it, right? So with this, we conclude over here. Next, we are going to discuss, derive the equation of motion and solve the problems based on the motion in a straight line. When you have motion in straight line, we assume the horizontal motion is either in towards x-axis or in the opposite direction. And if the motion is vertical, we'll see about that also, then it is either towards upward or towards downward, right? So the motion in straight line or motion in one dimension is, this is how we study, right? So that's all in this video. We'll continue with the motion in straight line, equations of motion in straight line, and the numericals in our next class. Thank you.